Audio Jungle.
Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Aditya Kurniawan dari Politeknik Kota Malang, DIS yang sedang dalam proses SERDOS 2022. Di video ini saya akan menyajikan PDD UKTPT untuk unjuk kinerja Tridhama Perguruan Tinggi yang dalam hal ini dalam hal pengajaran untuk SMART SERDOS 2022 dengan mata kuliah pilihan saya, yaitu mata kuliah Electropneumatic. Mata kuliah ini saya ajarkan mulai tahun 2015 dengan capaian pembelajaran, yaitu yang pertama mampu membedakan sinyal kontrol dan sinyal power. Yang kedua, mampu menyebutkan komponen-komponen elektropneumatik yang itu sangat penting untuk pembelajar di bidang elektropneumatik. Yang ketiga, yaitu mampu menggambar desain sirkuit dan melakukan simulasi di fluid sim dan juga melakukan simulasi di modul unjuk kerja yang sudah kita siapkan. Yang selanjutnya, mampu mendesain tekanan minimum sistem pneumatik untuk beban tertentu yang sudah dihitung di dalam Jobsheet yang telah disiapkan oleh mahasiswa. Materi pembelajaran yang saya ajarkan di dalam mata kuliah ini yaitu yang pertama adalah Power Supply Design, yang itu saya sampaikan dalam perkuliahan di dalam PPT saya, Directional Solenoid Valves, PE Converters, Magnetic Proximity Switch, S.ST yaitu Single Pole Single Throw, SPDT yaitu Single Pole Double Throw, DPST Switch, Relay Timer Module, Indicator Line Module, Counter Module, Displacement Step Diagram, Cylinder Force Calculation, Standard Labeling, dan Fluid Sim Simulation. Yang semuanya ini kami standarkan kepada Festo sebagai produk pneumatik yang saat ini menjadi standar di industri. Dan selanjutnya, pembelajaran ini saya lakukan dengan metode hybrid, tatap muka, daring, dan luring, serta proses pembelajaran ini saya lakukan dalam platform Moodle yang kami kembangkan, yaitu Moodle 3.0.10 dengan alamat lms.poltekom.ac.id, yang di dalamnya terdapat beberapa materi yang bisa di-download secara mandiri oleh mahasiswa, dan juga terdapat e-Jobsheet yang dimana mereka bisa membaca Jobsheet itu, mengerjakannya dan mengumpulkannya secara online, sehingga jika mereka terlambat mengumpulkan maka mereka tidak bisa lagi mengumpulkan. Termasuk juga untuk e-UTS, e-UAS, dan e-Remedi juga terdapat di dalam platform ini. Sebagai contoh, di e-UTS itu terdapat pada link LMS Poltekom AC ID dengan ID 1346 yang kami tampilkan di dalam layar. Sebagai pembiasaan pada bahasa internasional, untuk materi yang bersifat introduction dan pengenalan, saya menyampaikan materi saya dalam bahasa Inggris secara daring, dan setelah itu terdapat sesi demonstrasi pada modul latih elektropneumatik yang telah saya siapkan. Pada sesi akhir video ini, saya juga menyajikan contoh interaksi dengan mahasiswa berupa unjuk kerja dengan Jobsheet yang telah disiapkan pada mahasiswa semester 3, Prodi Teknik Mekatronika Politeknik Kota Malang, menggunakan produk penelitian saya yang berjudul Smart Helmet First Person View, yaitu set-fpv, sebagai perangkat teknologi pembelajaran tatap muka virtual semi-realistik pada kelas Praktikum Electropneumatic jarak jauh yang dibiayai oleh Seamolek pada tahun 2021. Hal ini sebagai jawaban saya, yaitu sebagai pengajar, karena melihat tantangan kelas praktikum Politeknik yang harus dilakukan secara maya saat pandemi COVID-19. Semoga berkenan dengan video yang saya sajikan dan selamat menonton. Assalamualaikum warahmatullahi wabarakatuh.
Right, sorry for the waiting.
So to remind you all about the material coverage of this session of this material, so we'll cover the first one is the introduction to electropneumatics. To join this session, it's actually you have to know about the pneumatics and the basics of pneumatics. The second one, I'll introduce you the electropneumatic components. Some of you may know the components very well. And the third one is about the nomenclature of standards using the ISO 55993 and ISO 12191 about the nomenclatures and naming. The number 4 is the introduction to split sim for designing and simulation. So we're going to use the split sim. It's a software, simulation software produced by Factor Manufacturing. So Factor manufactures pneumatics components and stuff. So they produce the simulation software as well. So we're going to use that, and you're going to use that as well as the Jobsheet or as the assignment for the sessions, the next 2 sessions. And number 5 is about the hydraulic system overview and the comparisons to pneumatics. The single objective of this session is actually for you to be able to do one simple electropneumatic system design using the split sim that you will install it yourself, and I will give you training on how to do it. I will give you demonstrations next meeting on how to do how to use the split sim software. Right. So before we continue our sessions and our lectures, it would be better if you redo some pneumatics recap, because maybe some of you have already forgotten, or maybe some of you this is your first time to hear the word pneumatics. So it would be better if you recap what is pneumatics about and so on, so we can continue the sessions from that time. So talking about pneumatics, we always thinking about what is this all about and what is this about. It's actually a tool used by the human. So we're using a lot of tools in our life. We're using computers. We're using engines. We're using cars. Using airplane and stuff. So this is just one of them, and maybe just known by some engineers, not others. So we call it pneumatics, and it's all about what you can see here is cloud producing some wind, and these trees is just following that wind. So pneumatics is just about this wind, the power of the wind, and how the wind can move objects. So it's also the same with this kite. Whenever you play kite, and the kite just the wind just flew your kite like wherever it goes, and you hold the kite and it flies away. So this powers is also utilized by using the wind. So the airplane is also the same as well. So it's using wind power. We call it air power or wind power to elevate the airplane. You know, airplane is very heavy. You can't move it. You can't lift it, but the wind can do that. So thinking about this wind and thinking about this air, it must be something behind the air and the wind. It must have some power inside the wind and the air. So what is pneumatics about? If you think about pneumatics, you think about the wind. If you think about pneumatics, and you think about the air. So if you know air, it's to surround us right now. We know air, we know wind, and So why pneumatic using air? Why not the others? I'll explain that question later. So you can see that this is the molecules of the air. There's nitrogen and carbon dioxide and oxygen, and this is the dry atmospheric percentage, which is does not include water. And so this is air that we know right now. So pneumatics is if we think about pneumatics, so we just think about the air. So all of it is about the air. So now the next questions that arise when you're thinking about the pneumatics is, what is actually the power or the air offers to us? So the air has some hidden power inside the air. So the pneumatic system is actually a tool, something like this. So we call it cylinders. It produces a linear motion. So it produces like linear motion because it's going like straight forward. It will be different with the motors. Electrical motors, it circulates around an axis, but this one is just moving forward just like this. So what moves this? We call it with stroke. This T shape colored in blue is we call it with stroke. What moves this one is actually an air. So how if I've got like a device that can pressurize an air? So we have a compressed air inside here. So we put it like in a solenoid valve or valve, and then this air or this compressed air will move these cylinders or move this probe downwards and upwards. We call it with expand and retract. So just say about the previous one, if we don't pressurize the air, we got like 1 atmosphere, it means like this one. So how if I can increase that atmospheric pressure to 2 or 3 atm or atmosphere? So this is the model of M5, which is a compressor. You can see the arrow here. The air is flowing through here. So this is the air input, or the air is flowing from the environment through this hole. And so like this, the air is getting inside the compressor. Then this is from the front of the device. This is just an example of the compressor. And the air will be flowing through a device called the compressor. So the compressor is just a device to compress an air. So we're going through this block here. We'll go to inside cylinder. What's called with this is called with the compressor head to the intake port. So we've got like intake port here, down here, and it will go through what is inside as a gasket. We've got like valve plates and so on. So actually the air is flowing through this so flowing through this way. So it's from the outside environment, it flows to this way, this hole, going to this way, this hole, and going inside and going further inside and going to the compressor head to the intake port. The intake port, we've got like 2 gaskets here. We've got the first gasket and the second gasket, which is like a hole. Then we've got like a flapper valve. It conceals the hole, and this is the hole on the right. So we've got the holes on the right and the holes on the left, which has a flapper valve. And this is the other side of the gasket. We've got like another hole and another flapper valve conceals the second hole, or the hole on the right. So this is how it works actually. Is whenever the motor here is rotating, there is a piston here going forwards and backwards, and it will just it will create a compressed air by letting the air going through this hole and going through this flapper valve and then going inside this gasket. But suddenly the air cannot going out again because it's just like this. So it works like a trap. If you know the mouse trap, the mouse can go inside but cannot go outside. So this air or the compressor is it works like a mouse trap or like an air trap. So the air can go inside but cannot go outside. So we can see that the air can go inside like this. You can see that this gasket here. So the air is going inside, but the air cannot go outside. So the red color here means that the air is getting pressurized inside the gasket. Then after that, this high pressure will be flowing through the other hole, which is flowing through the other cavity inside the compressor. So whenever this one is the second gasket, this one is the one on the bottom is the second gasket, the one on the top is the first gasket, pneumatic system. Even though this one is actually a simple one, but we've got like all of the toys here, we've got all of the components here. The first one is air compressor. You know how it works, and you know how it will compress air from the environment. 1 atmosphere go through this air compressor and it will produce 3 or 4 atmospheric pressure. It will produce air pressure, go to this tank. So it will from here go to this tank. It will fill it up with pressurized air, and it will go to these spray filters. We call it filters because it filters a lot of things. It filters the dust because you know the air in the environment, we've got a lot of dust and other unused materials that can make the performance of the pneumatic system it can make it worse, or it can make it like failure. It can create a failure in the system. So the air will go through this spray filter. It will go to the air dryer. So after here, we'll go to the air dryer because you know in the environment, the air in the environment, we've got like water molecules. So the air dryer works as the dryer for the air. So there is no water molecules in here. So the water molecules will stay in this dryer. So the dry air will go through the final filters. The final filters actually work the same things as the brake filters. So these two components work the same things, but this one is the brake filters, this one is the final filter. So it just make sure that all the dust gone and things like that. Then it will go to the manual blow valve. This valve is actually almost the same with your valve in your bathroom or in your water. So this manual blow valve is just like the water valve. So it will be the same with your water valve in the bathroom. And we'll go through this tube here. We've got like 3 black drains here to drain the water, if any. And it will go through the air tube, something like this. If you don't need to control the pressure, you just connect it to the air tube like this. But if you need to control the pressures and flow rate and others, you need to put it here. We call it filter regulator and lubricator, because some pneumatic system is very it's very sensitive to corrosions. So that's why we put lubricators inside, and it will make the cylinders and other pneumatic components move like freely, and it will slide easily because we put lubricators here. So this one, once again, from the air compressor, go to the air tank, go to the spray filters, go to the air dryers, go to the final filters, and go to the manual profile and the filter, regulator, and lubricators. So there's a clean air and lubricated air here. So there's a clean and lubricated air in these sections. It will go to the any pneumatics components that you have. So this is actually the simple pneumatic layout that we have. So for like the model for practice is like this. This is an example. So if I can show you this one.
Oke, kita mulai itu ya, proses untuk percobaan pertama menggunakan first person view. Kita coba praktek untuk Jobsheet yang pertama. Sebentar saya nyalakan dulu untuk first person view-nya. Oke, sudah kelihatan. Bisa menghadap ke meja kerja, ke meja untuk praktik. Nah. Bisa dipaskan mungkin yang lurus. Oke, sudah. Menghadap ke meja kerja. Oke, sudah. Nah, sekarang sebelum kita mulai praktiknya, mungkin ada baiknya kita berdoa sebentar. Berdoa dimulai. Oke, selesai. Oke, Mas Ahmad Mas Ahmad Hamdan, itu bisa disebutkan yang di depan itu peralatannya apa aja?
Untuk yang ini namanya double acting cylinder. Yang ini 2/2 valve with pneumatic. Yang ini 2/2 3/2 valve with push bottom. Yang ini 2 pressure valve. Yang ini shuttle valve. Dan ini sumber dari kompresor.
Oke, kita coba jadi pertama bisa di share screen-nya, mungkin share screen-nya di plugin-nya untuk yang jadi pertama. Oke, sudah.
Apa sudah tampil?
Sudah tampil. Di situ bisa disebutkan dulu yang untuk 1A bisa dipegang yang mana device-nya, komponennya yang mana, yang 1A.
Di dashboardnya ini tidak ada karena ini menggunakan double acting cylinder. Kalau di sini dan sebagai gantinya 1A adalah double acting cylinder yang ini.
Oke, dipegang itu ya, jadi penggantinya untuk double acting yang itu double acting. Untuk 1C3 bisa dipegang yang mana?
UKTPT 3 kita gunakan menggunakan pressure valve, terus pressure valve yaitu 3 komponen ini kita pilih salah satunya yang kita bisa gunakan.
Untuk satu itu yang normally open atau normally close?
Normally close. Jadi benda kerjanya di sini ada normally close.
Itu berarti pakai yang normally close ya. Ditekan dulu mana komponennya yang 1C1 sama 1C2. Oke.
Satu sama normally close berarti ini. Yang ini sama ini.
Oke. Oke, yang untuk 0Z bisa mengarahkan kamera kepalanya ke untuk 0Z gimana komponennya bisa ditekan?
Bawah ada komponensi.
Oke, sudah. Bisa dimulai untuk prakteknya dirangkai seperti yang sudah dibikin di Zoom. Oke, silakan dimulai.
Untuk rangkaiannya seperti ini. Dari sumber kompresor masuk ke kita menggunakan V1 yang ini, kemudian sumber lagi ke V2, kemudian ke pressure valve menuju ke double acting cylinder.
Oke, sudah yakin betul ya rangkaiannya? Lihat dulu, bisa minta tolong untuk menghadap ke mejanya. Menghadap ke mejanya, jangan bergerak, agak mundur sedikit, menunduk sedikit. Nah, dah, stop. Oke, bisa yang untuk normally close. Masuk ke input dari pressure valve ya, yang 1C1 dan 1C2. 1C3-nya itu ada di pressure valve, 1A-nya sudah masuk ke bagian ke expand ya. Jadi sudah di cek semua koneksi yang masih terbuka. Ya. Sudah ditemukan sudah dari kalau M itu berarti diceritakan gimana kalau M tombol 1.
Berikutnya jika A0 B0 maka silinder retract ataupun tidak ada pergerakan. Untuk A0 ataupun B1 jika tidak ada pergerakan. Untuk A1 B0 sama pada kebenarannya 0. Untuk A1 B1 maka akan terjadi perubahan yaitu silinder expand. Ini saya lepas semua Pak.